So I'm starting here. Example 4, we actually did yesterday. I just erased it. And we finished it completely, correct? I think I might have even asked you a question on example 5, but we'll just start from scratch like we hadn't done it at all. Okay. So this says the function k is defined by k of x equals all this stuff for -10 to 10. Which of the following statements about k is correct? Okay, so this is a calculator question. I'm not going to have you type it in today because I know y'all are capable of typing things, and there isn't one like this on the assignment, so I just kind of want to do it together so we can talk about some Desmos things. The other thing that you may or may not know, and I just realized now that we hadn't really talked about, is on the AP exam, half of, or part of it, it's not exactly half, we'll just say half of it, you're allowed to use a calculator. And Desmos is what we are going to use because it's the easiest thing to use. It doesn't do any more than the calculators that you're allowed to use. It's just more user-friendly, and y'all are familiar with it. But the other half, no calculator at all, okay? So we got to be able to do both kinds of things. But this would be a calculator question, and they're in 2 different sections of the exam. And we will talk a lot more about the calculator stuff, but this will kind of get us started in looking at some of the things we need to know how to do. So first thing is this equation right here. I mean, it looks yucky because it's got all the decimals in it, but you should be able to tell me what kind of equation it is. What kind of equation is that? And don't say ugly, because okay, but what else? Anybody? You know, I know you know. That would be a form. Okay, you're on the right. It's okay, you're thinking. Y'all know this. This isn't one of those things where I don't know if you really learned this. You all know it. You've been doing them for a couple years. So what? I heard it. Quadratic. And you know that by looking at what? The exponent. The highest exponent we have is x squared, so it's a quadratic function, right? I mean, the x squared wasn't first, but that's totally fine. So when I graph a quadratic, what's the name of the little shape we graph? Parabola. Okay, and my parabolas can either open up or they can open down. What does this one do? Open up or down? What do we look at? Yeah, you look at this term, right? And since that term is negative, this parabola opens what? Down. Okay, now this is a calculator question. We're not going to work this question without the calculator. Like, it's possible, but that would just be mean because the numbers are crazy. We might be able to guess, but we don't want to do that either. But just understanding those things can help you sometimes make sure, first of all, that you typed it into Desmos correctly, or that your answers make sense. Because if you do something and you're like, oh, well, that would mean it has to open up, then you know you're wrong or that's not the answer, something like that. So just being able to notice those things and know what it is you're working with is a good thing. So it goes on to say, so when we look at our answer choices, it's talking about positive and negative rate of change. So since we're talking about rate of change, what should we write down? The fun chart. And if you went through that whole quiz and didn't write the fun chart down once, that's a bad, real bad. So, I mean, maybe it is possible. I mean, you can do it without it. I wouldn't suggest it at this point, but I mean, it's possible that maybe you understand it that greatly at this point, but I doubt it. So if I'm looking for whether K has a positive or negative rate of change, that means this is what I'm looking at. On the function itself, I'm going to be looking at, is the function increasing or decreasing? Okay. And so let me show you in Desmos. Sorry, I need to actually look at the equations so I'm not flipping back and forth. All right, so I have typed it in. One thing I want you to notice is that I didn't just type in starting with the 3.16. This is called K of X. I named it K of X. That's an important thing for you to do in Desmos. Whatever it says on the paper is what we put in there. Would I still get the same graph if I left off the K of X? Absolutely, but I'll explain to you in a minute why that's a good habit to get in. I also restricted the domain because they gave me a restricted domain of -10 to 10. Now, I didn't necessarily have to do that because I could have just not looked at past that and understood that part, but I just went ahead because I wanted you to know that you can. It's not really something that's necessary for us. The other thing I could have done is not put in the domain restriction, but then put vertical lines here so I would at least know where it chops off. But either way, this is what we get when we graph what they told us that we have here, okay? And then we look on A, the first interval they're giving us is from -10 to 8.348. Now, I preloaded all this so it wouldn't take so long for me typing. But what you can do to make sure you're looking exactly at that, especially when the numbers are not great, is do vertical lines. That's why we need to know x equals a vertical line. So if I graph x equals -10 and x equals 8.348, then I can see, actually I can make this look better, I think. There we go. That's a little better for y'all to see in the back, maybe. So basically, between the blue line and the green line, that's the interval that we're talking about. And we're looking to see if our function, let's see what this says. This said, k has a positive rate of change. So if k has a positive rate of change, that would mean that the function is increasing. Is the function increasing on this entire interval? No. It increases, then decreases, so my answer is not A, right? So then the next one is -0.663. And between 8 and 5.605. So I put that it's between the purple line and the black line. Is the function increasing the whole time there? No. Is it increasing at all? Yeah. Yes, but don't let that confuse you, because this says if we're talking about this whole interval, if the rate of change is positive over that interval, that means the entire interval, which means the function would have to be increasing over the entire interval, and it's not. So the fact that it is a little bit doesn't matter. Okay. And then the next, so answer is not B. Then we go from -10, whoops, -10, let me take those out, to 2.470. So from blue line to red line, is the function increasing the whole time? Do you have a question? Or no, go ahead. You're doing, you can explain it to her. That's fine. Go ahead. I'm sorry. I'll stop talking to you. You just keep talking. Just keep going. Okay, so between blue and red, is it increasing the whole time? Yes, but what does C say? Negative. So is that my answer? No. Do we automatically circle D? No, we got to check it. So on D, I'm going from 2.47 to 10. This time it's decreasing over the entire interval. That means the rate of change is negative. That is what D says. That is my answer. Okay. So do you have to do the vertical lines? No, but otherwise it's difficult to figure out where those actual points are when they're not pretty numbers. Okay. And we'll do more of this stuff and I'll let you practice. But since there wasn't really one on the assignment, I didn't want to take the time to do the whole thing there. All right. So example 6, we're just going to completely skip for right now. But I want you to get your computers out. I want you to go to this website right here in yellow, desmos.com/testing/CV, blah, blah, blah. You also need to bookmark that somehow, whatever you can do to get back to it easily. What I'm in right now is the Desmos that you can log into. It's just plain old Desmos, all right? But that's the only place I can save things, so I don't have to go retype stuff. The Desmos testing, once you type that in, that's what it should look like with the green bar at the top, and it says College Board version. And before any of you tell me I have you blocked from not typing that in. If you type that in and you type it incorrectly, you're going to get there, okay? If you try to go to Google or you can't spell, that's going to be a problem, but you can get there, okay? So type all that in for me. And this version of Desmos is different than what you get to use in Algebra 1, because that version restricts some things that you are allowed to do. And I want you to get the assignment that I gave you yesterday. That's why we're doing this now. All right, so again, I know that Desmos is not new to you, and you should be pretty well versed in it, but there are some things that I want to make sure that you understand, that ways you have maybe not used it in the past that will be very beneficial to you and sometimes required of you. So on your assignment, we're going to look at and we're going to look at number 4, okay? Because number 4 is a calculator question. The rest are not. This says to use your graphing calculator to find the average rate of change of G over the following intervals. And here, be sure to show your setup for your computations. Do not type anything into Desmos yet, all right? Because on the calculator sections of this exam, you still have to show some process. Do you have to show every single step of everything? Absolutely not. But you also can't just have an answer, all right? So yesterday we talked about function notation some, and I showed you how to set things up. And so when we're going to go do average, what does average rate of change mean? Slope. Yeah, it's slope, right? And so we know that it's the change in y or the change over the change in x, and we need to write it in function notation. So before I worry about the calculator at all, this first interval these are my x's, right? It's the intervals of the domain. So I'm going to write, and the name of this guy is G, so this is going to be G of 1.5 minus G of 0.5 all over 1.5 minus 0.5. Okay? That step needs to be there. And when you do that, you make sure that you put minuses in between both of them and you have those numbers vertically lined up the correct way, all right? That is showing that you understand what rate of change is and how all this stuff works. Okay, everybody good on that? So now we go to Desmos, and you can use your actual keyboard. I have to use this digital one and it takes me forever. You're going to type in that G of X, including the G of X, all right? So G of X equals, and then just type in that equation that they gave you. And in this case, the graph itself is really irrelevant to me. It's there. It's beautiful. There you go. It's what a cubic looks like. But I don't even care that I can actually see the graph. It's irrelevant. Here's what I'm not doing. I'm not going to do this the long way or the difficult way. We're going to work smarter, not harder. So because we used function notation when we wrote that stuff down on our paper, and we actually identified this as G of X and used all the correct variables, if this was G of T, I could use T's instead of X's. So you can always use whatever is right there. In this next box, we're going to put what we typed up. We're going to type in what we wrote on our paper. Here's a little hint that I realize some of y'all don't necessarily know. I'm not going to lie. I'd used Desmos for a while before anybody showed me this. I didn't even think about it. But if I'm going to put in something I know before I start as a fraction, hit that division sign first, and it makes it a lot easier, right? Instead of trying to group them or whatever. So if you've been gatekeeping that secret from your neighbors, then shame on you, because I was very excited when somebody showed me that. All right, so then in here, we're going to type in, like I said, literally what you wrote on your paper. G of 1.5 minus G of 5 over 1.5. Oh, not 5, it's 0.5. Yeah, thank you. I'll go back and fix that. I'm not sure what I said, but I know I didn't type the right thing. There's a 0.5 there. There we go. I said it and did it wrong. Okay. So when you're done, there's your answer. Okay? That's it, 0.9. And so when you go to do the next one, you could just change those numbers and then you get the next one. Now you still have to write it down each time, but this is how we want you to use the calculator for this. The purpose of it is not to make it more complicated. The purpose of it is for you to understand the function notation and how all this stuff works. So let's talk a little bit about decimals, because in order for you to get credit on the free response stuff, in pre-cal and calculus, your answers have to be correct to at least 3 decimal places. All right. It's AP Stats is different. So if you're in that or have taken that, I think they use 4. I don't know because I've never taught it, but I just know it's different. Because we have to be correct to 3, that does not mean that we add digits here. If all you see is 1, that's all you write. If you see 30, you don't write 30. Okay. The AP rule is 3. It's technically at least 3. We write down 5 decimal places. I'll get into all the whys later. Right now, you just got to trust me. So you have not 5 digits. So this isn't a significant digits thing. Don't get it confused with science. Decimal, and then if there's a whole bunch there, you write the first 5 and you stop. That's called truncating, when you just stop. You can either truncate or you can round. AP will take either one. However, I'm going to train y'all to always truncate because some of y'all don't know how to round. And I don't want you to do all this stuff beautifully and then not get the point because you can't round a freaking number, okay? So you just stop and it's just easier, okay? And again, I'll explain why it's 5 later. Just trust me right now. But if all you see is 1, you put 1. All you see is 2, you put 2. You see 6, you can write 5. You can also write 6, 7, 8. That's a little much. We don't need to do that, okay? Any questions about that? Does that make sense to you? We're good so far? All right. And anytime I need to clarify that stuff, you need to ask, and it is fine to ask. It is fine to interrupt me in the middle of what I'm saying to ask me a question like that, all right? Okay, so you got 5 minutes left. That ain't enough time to get into AP Classroom. So finish number 4. And also B on number 4, I almost took it off because it stresses everybody out every year, but I'm going to leave it on there. But I'm going to tell you, I want you to think about it. Think about what it's asking. If you can't figure out what's going on, don't freak out about it. Don't stress out about it. Once everybody has done this assignment, we definitely will talk about it. It's trying to lead us into the next thing we start talking about. So maybe when you read it, it can make sense of what they're asking. And if not, it's totally fine. Okay, totally fine. But yeah, use your time wisely so you can at least get that done and then maybe work on some more of this. I'll just give you the time for that. We'll get into AP Classroom and something else on Monday.